Yes, I can record.
Okay, so this is your responsibility to record the session, okay? The both of
Inshallah.
you.
Okay. Okay.
Okay, guys, let's start the session. So, what we are going to start, we have discussed about the routing in our last session, but in today's session, we are going to discuss switching, the switching concept. And if you remember last time, we have a good session on routing. So what is switching and what kind of devices we use for switching? There is a common device which we call it as switch, the switch. And what is switch? Switch is it's simply a forwarding device. It's simply a forwarding device, just like a router. But there is a difference. There is a difference. All the devices which uses IP addresses, and IP addresses means the logical addresses. Logical addresses. All the devices which use IP addresses for their communication is called layer 3 device. It's called the layer 3 device. Layer 3 means the network layer of OSI reference model. And all the devices, they use MAC addresses. MAC addresses means the physical addresses, and you can also call them as the hardware addresses. All the devices which uses MAC addresses or physical addresses, hardware addresses for their communication is called layer 2 devices. And layer 2 means the data link layer of OSI reference model, the data link layer. So normally in networking, we have two kind of addresses. One is IP addresses and the other addresses are MAC addresses. As we know, IP addresses is a 32-bit addressing scheme, and we have number of classes, class A, class B, class C, D, and E. And in those, we have different host bits and we have different network bits. In class A, we have 8 bits that represents network. In class B, there are 16 bits who represents network. And class C, there are 24 bits who represents network. So the MAC address is a 48-bit address. The MAC address consists of 48-bit address. And this 48-bit address is further divided into two portions. First 24 bits represents the vendor. It represents the vendor, the manufacturer. And the rest 24 bits represents the user and the host. So normally what switches do, we have multiple of switches in the market. Some of them contains 24 ports and some of them contains 48 ports. This is a common standard. Although we have a number of switches, some of them having 8 ports, 16 ports, 20 ports. There are a number of vendors in the market and there are a number of models of the switches in the market. But this is the common practice in production network or in enterprise network. We normally use 24 port switch and 48 port switch. So if we take the example, if we have 24 port switch, what we can do, we can terminate 24 end user with that switch. For example, this is our first PC, this is our second user, this is our third end user. This might be server, there might be a printer, there might be some storage device. So we can add multiple devices on the switch. So my first question is why we use switch? Why we use switch? This is my first question from all of you. Yes.
To connect multiple things to a single computer.
A single computer. All right. Anyone else? Yes, please.
To make a network,
Sorry, I can't hear you clearly.
to make a network,
I can't hear you. I can't hear you.
Keep traffic going between two devices on the same network or multiple devices.
All right. Okay, guys, perfect. So,
I mean, it uses um, the MAC addresses to forward data accordingly. Ensures that the packet is sent to the destined to the receiver. Make sure that the receiver receives it using the MAC address. That's what I remember.
perfect, perfect. Okay, let me draw the topology which we have discussed last time. So we were having two routers, and then we were adding the switches inside the both branches, and then we were terminating, we were adding multiple end users, and over here we were terminating a server. So there might be two users, and inside the company, inside your private network, there might be 500 users, there might be thousands of users, and there might be hundred of users. So if I'm having multiple end users over here, and why I'm connecting all of them with a switch so that they would be able to communicate with each other. They would be able to communicate with each other. Because if you take your machine, you will find it out your PC have only one network interface card, only one NIC. And you can add multiples. For example, you can add two NIC, or maximum you can add three NIC. But if there are 50 end users and they want to communicate with each other, so it is impossible to connect all of them together directly. Because if you want to connect this machine to all of the rest devices, so how can you connect them? Because at least minimum it contains only two NIC or three NICs, so you can connect him with three multiple devices, but still you have 45 devices to connect, 46 devices to connect. So this is impossible to connect all the end devices together directly. So we need a device, and that device have multiple ports, and we connect all the devices with that centralized device, and then this device able them to communicate with each other, but on the basis of MAC addresses. Because if we talk about the switch, we have multiple layer switches. We have layer 2 switches and we have layer 3 switches. Layer 2 switches work only on the basis of MAC addresses. They only forward the frames on the basis of MAC addresses. But we have layer 3 switches, which we call them as multi-layer switches. This kind of switches, the multi-layer switches, has the capability of layer 2 and layer 3. That means they can work on the basis of MAC addresses and they can operate on the basis of IP addresses as well. But if we talk about purely on the layer 2 devices, the layer 2 switches, they only work on the basis of MAC addresses. So all the devices communicate with each other, and this happens just because this switch maintains a table which we call as MAC address table. It learns all the MAC addresses of all the machines and put them into a table and manage all the routing, all the forwarding between these end devices. So that's why we are having a switch, and we terminate all the end user with that switch. For example, if you want uh, to configure a server, this might be your web server, this might be your application server. So if all the users want to access this server in their private network, so this is impossible to connect all the devices directly with the server so that everyone can access that server. No. So what you will do, you will add a switch and you will connect that server with the switch, and all the rest devices are also have connected with the switch, so that now everyone can access the server by this device. I hope class is with me at this point.
Yes, Professor.
Yes, Sudeep.
Yes.
Okay.
Yes, sir.
So let me quickly draw a topology and let me show you. Okay, from here you can take any switch. For example, I'm taking S5700, and let me drop 4 pieces. So you can take any port, for example, port 1 with this PC, port number 2, the second PC, port number 3 of this switch with the third PC, and port number 4 of this switch with the fourth PC. And let me just start the devices. And we need to assign the IP addresses. So what I'm going to do, I'm going to assign IP addresses from the same network, for example, 192.168.1.1, and the subnet mask, and no need to assign the gateway right now. Okay, to PC2, I will assign 192.168.1.2 and the subnet mask. PC3, you can mention the name as well, for example, PC3. So 192.168.1.3 and the subnet mask. PC4, 192.168.1.4. So what if this PC1, and which is 192.168.1.1, this is a source, and this PC wants to communicate with destination, for example, with 192.168.1.4. So what you think? You would be able to communicate with that destination or not? What do you think? This PC wants to communicate with PC4. You should be able.
They should be able.
Okay.
I think so, no.
No.
Did we put IP addresses for switch ports so they can communicate? I think.
So you guys can see, I have given a command display MAC address table, and is showing me the nothing. It's showing nothing. So let me do one thing. I'm accessing this PC and I try to communicate with 192.168.1.4. And the people who were saying the communication wouldn't be done,
No,
wrong,
not.
communication would be happen. Why? Because all the PCs belongs to the same network, 192.168.1.0. They all belongs to the same network. And if they belong to the same network, on the same private network, they can communicate with each other. But what if these two PCs belongs to this network, for example, 192.168.1.0 network, and these two PCs belongs to 192.168.2.0 network, then they won't be able to communicate with each other until unless you perform routing. Because communication between two different networks is the responsibility of the router, not of the switch. So router is a device which enables you to communicate between two different networks. That's the job of the router. But this is switch. It won't allow you to communicate between two different networks. For example, if I'm changing the network of this PC4 and I'm going to change the network, and then I will try to communicate with 2.4, for example, with 2.4. So you can see I'm not able to communicate with that PC because it belongs to some different network. It's not in the same network. You're getting my point. So generally, if you talk about the layer 2 switches, you can communicate with each other if you are in the same network. But if you are in a different network, without doing routing, you cannot communicate with each other. All right. So again, I'm changing the network and I'm putting him into the same network. So why I'm able to communicate with all the PCs? For example, I'm trying to ping 1.2. You can see I can communicate with PC2. If I try to ping to PC3, you can see I can communicate with PC3 as well. And if I try to communicate with PC4, you can see I can communicate with him as well. What do you think, guys? This is a good thing or it's a bad thing that I can communicate with everyone? I can communicate with everyone.
It's a good thing.
Okay, it's a good thing. And for example, I'm going to tell you one most important features of the switch. By default, switches do broadcast. By default, switches do broadcast, but in actual, switches, they are a unicast device. Switch is a unicast device. But initially, they do broadcast. But after all, switch is a unicast device. Same like we have discussed about the router, that router is a unicast device only for data. Router is a unicast device only for data. In the same manner, what I'm saying switches do broadcast, and I'm mentioning initially, in starting, in the beginning, they do broadcast, but in actual, switches are the unicast devices. What does it mean? That means if I'm having one switch and I'm having 4 ports over here and connecting 4 end users, and their IPs are, for example, 192.168.1.1, and then 192.168.1.2. Then instead of writing the complete, I will write 1.3, and this is 1.4. These are the IP addresses of all the machines. So every machine have their own MAC address. So instead of writing the 48-bit MAC address, just to deliver the concept, I'm assuming that these machines, the MAC address of this machine is, for example, AA. The MAC address of this machine, which is 1.2, the MAC address of this machine is AB, and 1.3 having AC, and 1.4 having AD. So what's going to happen? What's going to happen? This switch, this switch is a very intelligent device. It's a very intelligent device. Why is intelligent? Because it manages the MAC address table. The MAC address table. It maintains the MAC address table. And why he maintains the MAC address table? Because whenever this particular source, and what is this source? This is 192.168.1.1, wants to communicate with this destination, for example, 1.4, because this PC only knows about the IP address of this machine, of the destination. This source doesn't have any information about the MAC address of this machine. This is understood. Because we cannot assign MAC addresses to the machines, so we only play with the IP addresses. Being a network administrator, you can assign multiple networks and multiple IP addresses, but you cannot assign the MAC addresses to the machine. This is by default. This is from the manufacturer side. So if I don't know the destination IP address, and also I don't know about the MAC address, then obviously I won't be able to communicate. If you don't have my number, you cannot contact with me. If you don't have my email, you cannot communicate with me. So definitely, if you are interested to talk with someone, so you should have at least one address. At least one address. It could be a mobile number, it could be your email address, it could be any source. But you should have at least one contact number, one address to whom you want to communicate. So this source only knows about the destination address, but you don't have any information about the MAC address. So what it will do, it will simply do the broadcast that I am a source, I am 1.1, and I'm looking for 1.4. I want to communicate with him. And this broadcast will be receiving from every interface, from every port of the switch. So it will do broadcast and it ask, is that you 1.4? You will say, no, I'm not 1.4, I'm 1.2. Then packet will be discarded. Then he will ask from him, is that you 1.4? He will say, no, I'm 1.3. And then this broadcast will be received by that PC and will ask, is that you 1.4? He says, yes, I am 1.4. And then he will ask, tell me, what is your MAC address? And he will reply that my MAC address is AD. And what is Switch doing behind this scenario? Switch is maintaining two things. What kind of things? the port number and the MAC address of the machine. The port number and the MAC address. For example, in the beginning, this machine flood the broadcast. And what I'm saying switch is very intelligent device. It learns the MAC address which is connected against this port. So it will put an entry into the MAC address table that against the port number 1, there is a machine whose MAC address is AA. And then every machine which is terminated in the same switch will be receiving that broadcast. But this is not the address of that machine. All will discard the traffic. Only this machine will reply to the specific source, which the person who is interested in the communication. It will simply do unicast to him that I'm 1.4. Tell me what you need. This port will ask, tell me what's your MAC address, and you'll say I'm connected in port number 4 and my MAC address is AD. So now in this communication, this switch has maintained the MAC address table of the source and the destination. And then again, the second case is, for example, now this machine is interested. So 1.2 is interested to communicate with 1.4. So now he knows 1.4 is at port number 4 and its MAC address is AD. Now at this time, switch will not do the broadcast. It will do simply the unicast. So if the destination entry exists in the MAC address table, switch do unicast. But if the destination entry does not exist in the MAC address table, simply switch do broadcast to find it out that where he is sitting right now. You got my point? So you need to understand when switches do broadcast and when switches do unicast. Switches only do the broadcast when the entry does not exist in the MAC address table. It simply do the broadcast. And when the destination entry exists in the MAC address table, they simply do unicast. Is that clear to everyone?
Yes, sir.
But
Yes.
this is the worst case. Why this is not a good thing? Just because, for example, if I'm having 200 users, the case is if I'm having 200 users and they all are sitting in multiple floors. For example, this is the 4th floor. This is the 3rd floor, the 2nd floor, and the 1st floor. For example, if I'm having 4 or 5 switches, you can add so many, depends on the requirement. Obviously, this is the 5th floor, this is the 3rd, this is the 2nd one, and that was the 1st one. So I have multiple end users on all the floors. And obviously, we need to connect all these switches together. Why I'm connecting all these switches together? Obviously, this is an organization. So on each floor, there might be different end users and they would like to communicate with each other in order to exchange the information, files, information, etc. So they are interested to communicate with each other. So there are multiple end users and they are sitting in multiple floors. What's going to happen if this PC1, the first person, wants to communicate with this specific destination, So this simple PC1 will generate will flood a broadcast. And tell me, if I'm having 200 user and one PC1 simply flood the broadcast, then how many users will receive that broadcast which is flooded by this PC1?
198.
198. Anyone else? This is simply like if we are having a big auditorium, and in that auditorium we have 200 students, and for example 200 people or 200 students, and one of these students come onto the stage and start speaking, start communicating, start screaming. If this one student screams out, how many students will be listening his speech?
Everyone.
199. Not everyone. 199. Obviously, if one PC do the broadcast, then 199 end user will be receiving that broadcast. That means this broadcast will be receiving on all the interfaces of the switch, from here to there, then from all the ports, then from all the ports, all the end user will be receiving that broadcast, and so forth. Now tell me, this is a good thing or bad thing? Aren't you using the resources of your devices, the bandwidth of the link? You are flooding the broadcast. In the network, broadcast is not a good thing. If you want to communicate one-to-one, or if you want to utilize the resources in a better way, this is not a good thing. So what we want, for example, in an organization, I'm having 50 end users and they belongs to IT, and 20 end users and they belongs to accounts department, and 30 end users they belongs to marketing department, and 20 end users and they belong to the production department, for example. And total, I'm having 50, 90, and 120. The total number of end users, they are 120. So what's going to happen? If one of the guy from IT, it do broadcast, that means 119 from every department will receive that broadcast. And this is not a good thing. This is against the privacy. This is a whole of security. This shouldn't be happen. So what we need to do, normally we call it as one broadcast domain. And that's the key feature of switch. That switch has one broadcast domain by default. Switches has one broadcast domain by default. By default means we can break them, we can configure, we can reduce, we can minimize one broadcast domains into multiple broadcast domains. This is broadcast. Broadcast means one PC is simply flooding the broadcast, then 119 receiving the broadcast in a particular domain, in particular this boundary. This boundary is called the domain. So this is one broadcast domain in which everyone is receiving the broadcast. So that's why I'm calling it as a one broadcast domain. So what we need to do, we need to isolate them. I need to isolate break one broadcast domain into 4 broadcast domains. So how we will do it, and what's the advantage of dividing the one broadcast domain into multiple, or right now in this case into 4 broadcast domain? Now the advantage is, if one guy who belongs to IT do the broadcast, only 49 will be receiving that broadcast, and they are the same guys who belongs to IT as well. And one of the guy from the marketing department do the broadcast, only 29 will be receiving that broadcast. We are isolating their broadcast domain. We are isolating their broadcast domain into multiple departments. If one of the guy from the account departments do the broadcast, only 19 will be receiving that broadcast. If one of the guy from the production network do the broadcast, only 19 will be receiving that broadcast. The broadcast domain into multiple broadcast domains, you can see if one person from any department do the broadcast, 199 was receiving that broadcast. And now see the factor. So you have minimized the broadcast flood. And what you are achieving, you are minimizing the utilization of your resources, your bandwidth, your processor utilization, your memory utilization, your bandwidth utilization. And this concept is called VLAN. This concept is called VLAN. To break one broadcast domain into multiple broadcast domain, this concept is called VLAN. And what is the VLAN? V means virtual local area network. This is still the LAN. This is still LAN. All the department belongs to the LAN, but we have isolated them virtually. We are isolated them virtually. And obviously, we need to assign some IDs. For example, I will say all the guys which belongs to IT department will now be isolated in VLAN 10. It could be any number. It could be any number from 1 to 4094, 4096 or 94, I guess. This is the range of VLANs. So this is an ID. This is an ID, VLAN ID. And for example, I say all the guys who belongs to the marketing department, now I'm going to isolate them into VLAN 20. And the guys who belongs to account department, I'm going to isolate them in VLAN 30. And the guys who belongs to the production department, I'm going to isolate them into VLAN 40. And now what's going to happen? Now the IT department, if they are sitting in VLAN 10, and the accounts department, they are sitting in VLAN 30, they won't be able to communicate with each other. They won't be receiving any broadcast. And they won't be able to communicate with each other as well. The account department would not be able to communicate with the production network, and the production network cannot communicate with the account department. The production department cannot communicate with the marketing department, and the marketing department cannot communicate with the production department. The production department cannot communicate with the IT department, and IT guys cannot communicate with the production guys. No one can communicate with each other. They will only communicate within the department. And within the department, all the PCs will be receiving the broadcast. This is clear to everyone. This is very important concept. In the production network, all the time, you are doing this kind of stuff. Afnan, very good question. Very good question. And the question is, if IT person wants to communicate with another person from the another department, how they communicate, we can allow them to communicate with each other. And this is another concept which we call as inter-VLAN routing. Inter-VLAN routing. So we need to perform routing. We need to perform routing if you want two different departments communicate with each other. So we need to perform routing between the VLANs, inter VLANs, routing. We need to perform routing. So we can do that. But by default, if you create multiple VLANs and you isolate multiple departments in the VLANs, they won't be able to communicate with each other. But if you want to allow some department to communicate with another department, we can do that as well. And that concept is called inter-VLAN routing, inter-VLAN routing. And this topic is not included in our today's course outline, but I will give you the idea how we can do that. No problem.
Sir, I have one question.
So,
Yeah, but when we will do inter VLAN routing, like for example, if IT wants to communicate with accounting,
yeah.
when they will try to contact with the accounting, will there be a broadcast among these 20 people of this accounts people?
No, you can put the restrictions like we have discussed about the ACLs. For example, if you want uh, this guy, this one guy only to communicate with the account department, and in the account department there is only one guy. You only want that the both person can communicate with each other only, and the rest of the guys cannot communicate with each other. So we will implement some policies like ACL. So we will restrict all the other guys and will only allow the specific guy and which you want to wish to communicate with each other. So we can do that, but we need to apply some policies because you are allowing by performing inter-VLAN routing, all the guys will be communicating with each other. But if you want to stop some guys that they don't communicate with each other and some of them you want to allow, then you have to make policies like the ACLs. You got my point?
Yes, sir. Thank you.
Yes, anyone else? Any question, guys? Okay, let's do that. That how we can isolate them. Till yet you can see PC1 can communicate with every device, with 1.4, with 1.3, and with 1.2 as well. But now the company has changed the policy and they want this port 1 of the switch and port 2 of the switch. We are going to bind them, we are going to map them, we are going to isolate them into VLAN 10. For example, VLAN 10 we are creating for IT department. And the port 3 and 4 of the same switch, we are going to map them with VLAN 20. And for example, this VLAN 20 is for the accountant guys. This port number 3 and 4. Just remember one thing, nothing is related to PC with the VLAN. You don't even know what is VLAN. This is all about on the interfaces of the switches, All right. So what we need to do, first of all, we need to create a VLAN. And let me show you one thing. By default, there is a VLAN, which is VLAN 1, and all the interfaces, all the ports of the switch, by default, they are the member of VLAN 1. Let me show you. So display VLAN. So you can see there is one VLAN by default, VLAN ID 1. This is by default. And you can see all the ports, all the 24 ports are the member of VLAN 1 by default. And this is called one broadcast domain. That's why all the devices can communicate with each other. You can see you mean up, first 4 ports are up because we have terminated end users. in the respective ports. And all the rest ports from 5 to 24, they are in the down state. All right. But why they are able to communicate with each other? Because they are in the same VLAN, which is VLAN 1, which is VLAN 1. And that is called one broadcast domain. That's why to the VLAN 1. But now what we want? We want to create a VLAN with ID 10. And I want this port and this port to be a member of VLAN 10 now. Just leave this VLAN and become the member of VLAN 10. And the guys who are sitting in the port number 3 and the port number 4, I want them to join this VLAN, VLAN 20, and leave this VLAN, VLAN 1, which is by default. So that's what we want to do. So how we can do that? How we can achieve that? The method is very simple. The method is very simple. First of all, you need to create VLANs. You need to create VLANs. For example, you need to give the command VLAN. And if you want to create both VLANs simultaneously, you have a command VLAN batch, and for example, 10 and 20. And if you write 10 to 20, then it will create the VLANs from 10 to 20, 10, 11, 12, 13, and so on till 20. But if you simply write 10 and then 20, it will only create two VLANs. Just hit the enter button and now verify by giving this command display VLAN. Now guys, you can see we have created two VLANs, VLAN 10 and VLAN 20. But still, these four ports are the member of VLAN 1. So definitely by simply creating a VLANs, port cannot be associated automatically. So we need to jump to this port and I need to tell him, now you need to join this VLAN, VLAN 10. And I will also go to this interface and I need to tell him, you should be the member of VLAN 10. Why? Because I want this. This is my scenario. And I need to tell these two ports, just break the membership with VLAN 1 and join this particular VLAN, VLAN 20. All right. So how we can do that? This is very simple. We'll go to first interface gig 0/0/1, and you need to write two commands. First, port link type access. And why I'm saying this, port link type access. Right now, where I am inside the interface. Inside the interface means inside the port. I am saying to that port, your link type should be access. Your link type should be access. Why I'm saying access? All the devices, which we call them as end users, these are the edges of the network, edge, where our network terminated. And all the rest of the devices, for example, if we have a connectivity between two switches, this is called known edge. This is called known edge. Because in between this link, there are two devices and further there are multiple devices. So this portion we call it as edge, and this portion is called known edges. So normally, whenever we talk about the end users, the link type should be access. The link type should be access. And whenever you connect two devices, for example, between the switches, you always configure this link as a trunk link. Trunk means from that link, there is a single link and there are multiple VLANs. So all the traffic of multiple VLANs will go through this link. So that's why this link should be configured as a trunk. But whenever you talk about the edges of the devices, edges of the network, normally we configure them as an access, because there is, in this link, there would be the traffic of this machine only. There's not multiple devices. There's a simple one device, which is over PC1. So normally this PC connected with the switch by the access link. And between the switches, this link should be configured as trunk. So that's why these are the edges. These are the edges. So we are going to configure this link type as access. First command. And the second command, port default VLAN 10. What does that mean? That means I'm telling to this interface, now you are a member of VLAN 10. I'm mapping this interface with this VLAN. I'm binding this interface with this VLAN. I'm associating this interface with this VLAN. So you can use multiple words. Now you have to associate this interface with this VLAN. You have to bind, you have to map. So let me press the enter. And you need to verify, but let me add another interface. For example, to port number 2, I will give the same command. For example, port link type should be access, and port default VLAN 10. I'm also telling to this interface, which interface? This second interface, you are also going to be a member of VLAN 10. And after this, let me verify display VLAN. Now you guys can see the ports 1 and 2 as leave this VLAN 1, and now the both are the member of VLAN 10. And same we need to do for interface 3 and for interface 4. So I'm going to repeat it again. So now I need to go to interface 0/0/3. And what I will say port link type should be access, because we are talking about the edges, and the port default VLAN 20, because I want this port number 3. One of the accounted guy is sitting against this interface, so I need to isolate him into VLAN 20. So that's what I'm doing again. And the same thing we need to do for port number 4. So let me jump into the port number 4, and then I will say port link type access, and port default VLAN 20, and that's it. So how you can verify? Display VLAN. Now you guys can see they are mapped with VLAN 20, and the first two ports have been mapped with VLAN 10. Any question, guys? So far, so good.
Yeah, it's good. I think it's clear.
So now this machine would be able to communicate with PC3 and PC4.
I think so. No, we need to provide a routing for that. I think so.
Okay. Anyone else? guess the guys are confused or they are sleepy. Okay, let me try. I'm sitting in PC1, which is 1.1, and from here I will try to communicate with 1.2. With 1.2, he will communicate.
Yes. There is
1.2,
any
yeah.
Yes,
They
because
are in the same VLAN. VLAN 10.
see the reply is coming. But if I try to ping to 1.4 and that guy belongs to VLAN 20, belongs to different VLAN. So now you guys, I'm not able to communicate with that guy. And I also not able to communicate with PC3 because the both guys belongs to VLAN 20. So what we have done, what we have achieved, we have divided one broadcast domain into two broadcast domains. One is VLAN 10 and the other is VLAN 20. This department, as we assumed that this department belongs to IT and this VLAN 20 belongs to the account department. And what we have done, we have isolated these two departments. They only can communicate with each other. They can communicate with each other, but they are not able to communicate with the different VLANs. Inside the department, they can communicate, but outside the department, they won't be able to communicate. So that's what we have achieved by the concept of VLAN, Virtual Local Area Network. And what is the major advantage? What is the major advantage? Can you any one of you from can explain this concept? What the major advantage of creating the VLAN?
Maintain the security of a network.
All right. What else?
Improve performance of the network.
Efficient performance and
I think so saving time.
saving time. How can we how we are saving the time?
I mean, like for example, if PC1 wants to communicate with PC4, then there will be a broadcasting. Like it will be going to each and every one. So
Yes.
when we divide it, and it will go only to a single one, which is inside its own VLAN.
This communication is very fast. We have not we have no concern with the timing, but I want to listen another good answer which is given by Afnan to save resources. Obviously, we achieve the purpose of security. We are saving our resources. This is a major concern. We want to save our resources. All right. You are good as well. Your answer is good as well. But the main advantages is to reduce the broadcast into multiple broadcasts. That means to reduce the broadcast flood, to minimize the broadcast flood. And if you minimize the broadcast flood, obviously in the back end you are less utilizing your resources, the bandwidth and the physical resources of the devices, for example, the processor, the memory utilization, the buffering, and all the things, all the stuff. So far, so good, guys. So, what if I have a second floor, and on the second floor I have another switch, and on the second floor again I have two guys which belongs to IT and two guys which belongs to the account department. All right, and obviously we need to connect them with a switch. All right, now also we need to configure. I'm going to take the last port of this switch and the last port of the opposite switch. And let me start these devices as well. So what I'm going to do, I'm going to find the IP addresses. For example, 192.168.1.5. Okay. And then 1.6 to PC6. 192.168.1.6 and 255 and 255. And PC7, I'm going to assign 192.168.1.7 mask with /24 and PC8 168.1.8. So yes, Imad.
If we have two PCs in same VLAN but different network, they will able to communicate or not?
You are saying
Same VLAN but different network.
different network. Obviously, I have shown you already if they are in the same VLAN. In fact, they are in the same VLAN. All are in VLAN 1. But these two devices are in 192.168.1.0 network, and these two devices belongs to 192.168.2.0 network. They won't be able to communicate with each other because by default they are in VLAN 1.
Correct. Okay, thank you.
They belongs to the different network, so without performing routing, they won't be able to communicate with each other. Okay. So the case is this is over VLAN 10. Already we have put them into VLAN 10, and these are the IT guys, and we have put them into VLAN 20, and these are the accountant guys. And the same scenario I want in the second floor. The first two guys also, they are my IT persons, and they are in the same VLAN in the IT. And the rest two guys, they also my accountant guys, and they also belongs to VLAN 20 as well. So I want them to communicate with each other. The IT guys, they are sitting in the first floor, should be able to communicate with the IT guys who are sitting on the second floor, because there are some circumstances they should be able to communicate with each other in any kind of services they want in the first floor or in the second floor. So the same for the accountant guys. So what we need to do, we need to create the VLANs, and we need to assign port number 1 and 2 with VLAN 10, and we need to create a VLAN 20, and we need to map this port and this port number 3 and 4 with VLAN 20, and port number 1 and 2 we need to map with VLAN 10 as well. The same configurations which we have done in this switch. So I'm going to do it again so you guys can see if you still don't understand how to do that. So in the name system switch 2, for example, or the second floor switch. So first of all, you need to create VLAN 10 and 20. Sorry, by the and VLAN badge, then 10 and 20. If you want to create a single VLAN, you can create them as well. VLAN 10 and then quit, and then VLAN 20. You can create individually or you can create at once. Okay, so now you need to map interface 1 and 2 with VLAN 10. So we will jump into interface 1, 0/0/1, and you need to set this link type as access, and you need to map this interface with VLAN 10, and also you need to map second interface with the same VLAN. Okay, I have done it. So let me show you quickly. Display VLAN. I'm doing the same configurations which we have done a few minutes ago. So you can see the VLAN 10, and I have mapped 1 and 2 with VLAN 10. The same thing I need to do for interface 3 and 4, and I need to map them with VLAN 20. So how I will do that? So I will jump into the third interface, and I will give the same commands. Port link type access, and port default VLAN should be 20. And then the fourth interface 0/0/4, and port link type access, and the port default VLAN 20. Play VLAN. You can see the port number 3 and 4 has been mapped with VLAN 20, and 1 and 2 have been mapped with VLAN 10. So let me verify by pinging 192.168.1.6. I'm pinging from 1.5 to 1.6, and we are the same guys. We both belongs to VLAN 10, so we are communicating with each other. But if I try to ping to 1.8, so you can see we are not able to communicate with each other. Okay, fine. Now I want to communicate from this PC. This guy, belongs to VLAN 10, and I want to communicate with PC5, and also, this guy belongs to VLAN 10. That means both are in the same VLAN, VLAN 10. So should I communicate? No. Why? Why I cannot communicate?
Because we have to create trunk between switch 1 and switch 2 and allow pass VLAN 10 through it.
Perfect. As I told you, this is the non-edge. This is the non-edge. So this link, especially this interface 24 and the same interface on the other side, it should be configured as trunk, the first thing. And you need to permit these VLANs. For example, over here we are having VLAN 10, or over here we are having VLAN 20. So I need to permit these VLANs traffic over this trunk. Otherwise, you can see the traffic wouldn't be forwarding on this link. For example, from PC1, I try to ping to 192.168.1.5, and this is the IT guy. We are the same guy, but I'm not able to communicate. Also, the 1.6 is in the same department. He's an IT guy, but I'm still not able to communicate with him as well. So what we need to do, we need to configure this link as a trunk. And how we can do that? It's very simple. This non-edge is connected with port number 24. So the same configuration which I'm going to do on this switch, I need to do the same thing over the other switch. So how we can make this link as a trunk? This is very simple. Just jump into the same interface 0/0/24, and what you need to do, you need to set port link type, and now at this time you need to say trunk. Whenever you talk about the edges, you say this link type should be access. But whenever you talk about the non-edges, you need to set link type as trunk. And then you need to give the permit port, trunk, allow pass, VLAN, and let's check it. You can permit all to all VLANs, or you can permit to the specific VLANs. For example, I need to permit VLAN 10 and 20 only, 10 and 20. And if you want to specify a specific range, you can say 10 to 20. That means now it will allow all the VLANs from 10 to 20. 10 to 20 means 10, 11, 12, 13, and so on. But if you simply write 10 and 20, then 30, that means it's going to allow only 3 VLANs, 10, 20, and 30. But in our case, we have only 2 VLANs, VLAN 10 and 20. So you need to put that command as well. And the same configurations you need to do on the other switch. So you will jump in the same interface because we have the same interfaces at both sides. So what you need to say port link type should be trunk because this is non-edge, and then port trunk allow pass VLAN 10 and 20. 10 and 20. And now just try to ping with the same guy, and now you can see the reply is coming from 1.6. And also you can see the reply is coming from 1.5 because we just configured the non-edge as a trunk. And the accountant guys wants to communicate with either, they can also communicate. So try to ping 192.168 dot with 1.7, you can see I'm getting the response. And if you want to communicate with 1.8, you can also communicate. So far, so good, guys. If you have any question, you can ask.
No, sir, it's clear.
It's clear for me, so no questions.
All right. None, why we need to differentiate between VLAN 10 and 20? Although when I'm having a console of switch 1, for example, I'm taking the console of switch 1, I can change the name of that switch. For example, sysname switch, and you can put the first floor. So that's how you will distinguish that this is for. So you will see if you are accessing the first floor switch, obviously all the VLANs belong to the first switch, first floor. And if you want to check, and obviously you might be using the network addressing scheme. So you need to understand where we have which segment in the first floor and what segment we are using in the second floor for the IT guys. So that's how you can differentiate. But otherwise, there is no mechanism that you differentiate that VLAN belongs to first floor and that VLAN, because the VLAN ID is same. So you can set the name of VLAN as well. For example, if you create a VLAN, for example, VLAN 30, and you want to give it a name, so you can give a name. Let me put a question mark. So access VLAN there is no command in Huawei. It should be, there should be.
Maybe description.
Description. Yeah, description. We can, in Cisco, we use name over here. This is description. So you can set any name, for example, IT, and you can put first floor, or it could be any VLAN. So that's how you can identify. All right. So display VLAN, by giving this command, you can see is not mentioning the name description. All right, there is no mechanism. There is no mechanism. You can see this is over here, the description, that VLAN 30, and the description is this is the IT VLAN, for example, and this guy, this VLANs is have been created in the first floor switch. All right, so that's how you can differentiate. Okay, that's all about the VLAN. And we didn't talk about the VLANs only. We have talked about the port link types. Port link types. First was access, and the second one is trunk. So where we need to configure access and where we need to configure trunk, that's what we have done. So let me start another topic. This is very interesting and this is quite lengthy. For example, in this topology, for example, if we talk about this topology, what's the drawback? What's the drawback in this topology? What's the drawback? You need to figure it out. What's the drawback in this topology if the IT guys are communicating with the same guys and the account departments are communicating with the same guys, but they are sitting on the different floors? Is there any drawback in this topology? Is there any drawback? You need to figure it out. Yes. Yes, guys. Is there any drawback?
No, I don't think there is, but I don't know.
Okay. Guys, this is a single point of failure, single point of failure. If this link goes down, if this port goes down, all the entire communication between the same VLANs would stop. This is a single point of failure. If this link goes down, all the communication between the VLANs, between the floors won't be working. So what we need to do, for example, if I'm having two switches, this one and this one, we are adding one trunk between these two switches so that all the devices across these two switches can communicate with each other. That is our purpose, to configure a trunk. But again, what I'm saying this is a single point of failure. So we can't rely on a single trunk. So what we need to do, we need to add link, another backup link. We need to add another backup link so that if this link goes down, if something happened with that link, all the traffic wouldn't be stopped. The traffic will adopt the alternate path, so that without any interruption, they all will be able to communicate with each other. Perfect, seems perfect. But again, there is a drawback. Again, there is a drawback of putting the backup. What could be the drawback? Initially, switches do broadcast. If I'm having two active links, it will create a broadcast loop inside the fabric of the switch, inside the fabric of the switch. And all the network will be chalked down. All network will be chalked because this is the closed circuit. This will form a closed circuit and this will make a loop between these two switches. And the entire communication between the edges will be stopped. You're getting my point, what I'm trying to deliver. I was
Yes, sir.
adding the backup link. I was adding the backup link for the safe side, but instead of supporting me, it is creating loops. It is simply creating loops in my network. And this is very dangerous situation whenever the loops creates in your network. All the network will be chalked down. All the services will be stopped down. So what we need to do, the first solution is we need to put this interface in the shutdown state. In the shutdown state. Normally, I will be using that link for forwarding the traffic, and this link, I will put this link into the shutdown state because this is my backup link. This is my backup link. And if anytime on any specific date or day, this link goes down, immediately I need to put this link into the forwarding state. And how we do that, you know very well. I will jump into the interface, for example, interface gig 0/0/1. And I will say undo shutdown, undo, undo shutdown. And if you want to shut it down, you will simply say shut down. So that's how we down the link and that's how we up the link. So in the starting, if this link is working fine, it is in forwarding state, I will put this link into the shutdown state so that loops cannot be created. But immediately, if this link goes down, I need to put this interface into the up state, the forwarding state. And how I can do that? I will go to this interface and I will say undo shutdown. And after a few seconds, this link will be in the forwarding state. This is the static solution. This is the static solution. Static solutions mean this is the manual solution. Manual solution. All the time you need to look after if this link is in a forwarding state, and if you are sitting in the data center and where you have 500 switches, the 1,000 switches, the number of switches and the number of backup links, how will you maintain that manually? You cannot go and to check every single switch. What is the backup link? What is the forwarding state? Which link is the forwarding state? Which link has goes down? This is impossible when you talk about the enterprise network and the production network. Okay, fine. If you are having two switches inside your department, you can manage that by the static way. But this is not the recommendation in the production network. So what we need to do, we should have a dynamic solution. We should have a dynamic solution. And the dynamic solution is the STP. And what is STP? STP is spanning tree protocol. Spanning tree protocol. It's an open standard by IEEE 802.1d. Open standard. STP, spanning tree protocol. So what the responsibility of this protocol? It simply prevents loop. How it prevents from the loop? Obviously, if you draw the same topology and we have two trunks between these two switches, And for example, somehow STP is running by default on every switch. We don't need to enable this protocol on the switches. This is by default enabled on every switch. Either it is Cisco, either it is Huawei. This is enabled by default. So it will elect one interface in the forwarding state that you will send the traffic, and you need to sleep. STP will put this interface into the block state or alternate state. It will put this interface into the sleeping mode. Okay, you may have rest until unless this link goes down. And if this link goes down, immediately STP will put this state into the forwarding state. You got my point? So now I don't need to check this interface. I don't need to put this into the shutdown state. I don't need to put into the undo shutdown state. Simply STP will take care of this. This protocol will take care of this thing. I don't need to go to every individual switch, and I need to check what is the backup and what is the link which is current in forwarding state, which link goes down, which interface I need to make it up. I don't care. This responsibility is taken by STP, that I will do that. And how he do that, we will discuss it in a later on session. But the concept is what STP do. For example, if you are having two switches, this is switch A and this is switch B, and you have multiple backup links. So STP will allow only one link in the forwarding state, and the rest of the links, STP will put them into the block state. Every link, it will put it into the block state, because it creates loop. If you have one backup, or you can have two backups, the number of backups you have, the number of loops increases. For example, one loop can be created over here, one loop can be created over here, and one loop can be created over here. If STP don't put any interface into the block state, then what's going to happen? There is one loop, there is another loop, there is another loop, there is another loop, there is another loop. There are so many loops. So what STP do? STP put all the backup links into the block state. And if the first link goes down, immediately after a few seconds, there are some timers of STP. STP will put the second link into the forwarding state. Now the traffic will pass through the second link. If again this link goes down, STP will put all the traffic into the third link and will put this link into the forwarding state. And so on and so forth. It's not a good thing. We will discuss this later, but this is the good thing what STP do. It prevents from loop. It's a loop avoidance mechanism, and which is by default enabled in every switches. I hope class is with me.
Yes, sir.
Yes, sir.
So the question is how STP decides that which interface I need to put in the forwarding state and which interface I need to put into the blocking state. How it identifies. So there is an algorithm which we called it as STA. The algorithm of STP is STA, spanning tree algorithm. And how it calculates, how it determines, this is very complicated. Guys, this is going to be very complicated. So you need to be focused and you need to be tuned, because this is interesting as well as this is very complicated. So how HTTP works. So there are a few terms you need to remember. The first term, you need to remember these terminologies which I'm going to write. The first term is the root bridge. The root bridge. I'm not going to tell anything right now. I'm just telling you the terminologies. I will show you these terminologies. So root bridge, I will write it as RB. In short, I will write it as RB, root bridge. Then there is another term which we called as designated port, which we called as DP. This is not your display picture, but this is designated port. Then there is another term which we call it as root port, the root port, and we call it as RP, the root port. And there are another switches which we call as non-root bridges, non-root bridge, and we call it as NRB, non-root bridge. So guys, you need to remember these terminologies, only the terminologies: root bridge, designated port, which is DP, root port, RP, and the non-root bridge, that means NRB, non-root bridge. These roles, these two roles are given to the entire switch. For example, a switch can be a root bridge, a switch can be a non-root bridge. So these are the statuses of the switches, the entire switches. But these two words, as you can see, I'm writing port over here. That means these statuses are given to some specific port of switch. So now, whenever I say root bridge, that means I'm talking about the switch. Whenever I say the non-root bridge, that means I'm talking about the switch. But whenever I call DP, whenever I call RP, that means I'm talking about the particular port of the switch, the particular port of the switch. For example, this is a switch. I can say this is the root bridge. That means the entire switch status is the root bridge. And if I say the port number 24 is DP, designated port, that means I'm talking about the particular port of that root bridge. So you need to differentiate what I'm trying to tell you people. These are the terminologies. So what are these terminologies? We will talk about it, but right now I'm just mentioning their names, introducing to all of you with the names only. So if we want to understand the algorithm, the spanning tree algorithm, we need to follow 3 steps. I'm writing steps over here. And the first step is find out the root bridge per network. That means you need to figure out if you are having multiple switches in a network, this is the network. For example, this is a network. In this complete network, there should be one root bridge. So you need to figure it out. Who is the root bridge? So find out the root bridge per network. That means if you are having a one network, that means there should be one root bridge. So you need to elect root bridge first. Then the second step is you need to figure out the designated port per segment. And what is the segment? This is the segment. This is, for example, segment 1. This is the segment 2, and this is your segment 3. And by combining the segments, we create a network. So the link which connects two non-edges is called segment. The link which connects two non-edges is called a segment. And by combining segments, we complete the picture of network. So this is a segment. That means in one segment, there should be one designated port. Either this might be designated port or this might be designated port. In segment 2, there should be one designated port. Either it could be designated port or this port could be designated port. And in segment 3, obviously, you might be having one designated port. So in this network, we have total 3 segments. So how many DPs should I have, guys? If I'm having 3 segments in this network, how many DPs should be there?
I think so. 3.
3.
Perfect, perfect. If I'm having 3 segments, then that means there should be 3 DPs. There should be 3 DPs. And the last step is you need to figure out the root port per non-root bridge. Other than root bridge, for example, in this network, this switch has been elected as the root bridge. Then rest of the switches are called non-root bridges, the non-root bridges. The rest of the switches are called non-root bridges, So you need to figure out on the non-root bridges which ports should be elected as a root port. For example, in this network, in this complete network, how many root bridges I'm having? Obviously, one switch has been elected as a root bridge. So I have left only 2 switches and both are non-root bridges. So in this network, I'm having 2 non-root bridges. That means there should be 2 root ports. So I'm still introducing the terminologies. Network means you can see this is the complete network. And segments, every link between 2 non-edges is a segment. And other than root bridge, all the rest switches are called non-root bridge. So we need to understand these terms and we need to follow these steps. Then this algorithm is very easy if you successfully follow these 3 steps. But this one is going to be complicated for you people. This second step. If you understand the second step, then the third step would be easy for you. So I'm not starting this algorithm right now because we are going to have a break because today is Friday. So I need to go to offer the Jummah prayer. So I'm not going to start these steps. We will start after the break and we will continue until we're done. So have a break. Let's have a break of how many time? Okay. So guys, I will be back, I guess. So guys, when you want to be back?
Yeah, after 1 hour is good, I think, because it's 10:50 right now, and 11:38 will be the Friday prayer. So 1 hour is good.
1 hour is good, but there's some time difference. Okay.
Sir, let's back by 12 o'clock. It's the best time.
Okay, lunch break. I guess at my time 12
It will be 12:10.
12 12:15 from your side. All right.
Okay, that's good.
Okay, so okay, fine. Okay, we'll see you. We'll see you, inshallah. Take care.
Inshallah, you too.